Hello, grade 7s. In today's lesson, we're going to learn how to calculate the range of a data set and how to identify outliers in a data set, with our learning outcome being to demonstrate an understanding of range and outliers. The range in a data set is the positive difference between the largest and smallest values in a set of data. Usually the way we want to calculate range is when we're given a set of data, we want to write it in ascending order. So from the smallest value to the largest value. And then if we take the largest value and subtract the smallest value, that is what the range is. And as long as we go largest minus smallest, we're always going to get a positive difference. To calculate the range, you would take the maximum value in the data set and then subtract the minimum value in the data set. And subtraction is a difference, where max minus min, again, will give you a positive difference. We can use an abbreviated formula to calculate this. Range is equal to max for the maximum value, subtract min for the minimum value. Outliers are values that are either substantially larger or smaller than all other values in a set of data. When you look at a set of data and you, again, arrange it in ascending order, usually, maybe not usually, but sometimes the smallest or the largest values will be way off compared to all the other values in the data set. It almost seems like they don't belong, like they stick out like a sore thumb. Any values that stick out like a sore thumb, we classify them as being an outlier. And in a data set, you can have one outlier, you could have two outliers, you could have several outliers, or it's possible that if the data is consistent, you can have no outliers. Okay, so let's do 3 examples where we're going to calculate the range and also calculate the not calculate the outliers, determine the outliers in a set of data. Now, first things first, to most easily identify the max and the min values, we want to take this data set and write it in ascending order. Okay, so from smallest to biggest, we start off with 5 is the smallest number. And then we would have 19. And then we would have 20. And then we'd have 28. And that occurs a couple of times. 28, 28. And then we would have 31. And then 32. And then 35. And then 61. So from smallest to biggest, we have 5, 19, 20, 28, 28, 31, 32, 35, 61. Let's calculate the range first. So to calculate the range, we'll use that equation. Range is equal to max minus min, which is equal to the maximum value in the data set is 61. If you rewrite this in ascending order, the maximum value will always be on the right-hand side of the data set. The minimum value would be the number you start with, so that would be 5. Therefore, 61 minus 5, you would get a range equal to 56. The outliers are, you're going to find them typically at the start of the list or at the end of the list. And what you want to do is you want to look at those numbers and then compare them to the other values in the list and see if they're close. Okay, so the first number is 5. Is 5 anywhere close to the rest of the numbers? Not really. Like 5 is 14 off from 19. So I would classify 5 as being an outlier. Then let's look at the other end of the data set. 61. Is 61 close to 35, 32, etc.? No. Again, it's way off. So that would also be an outlying data point. So we have two of them. We have 5 and we have 61. B. Once again, we want to take this list and write in an ascending order. So I believe the smallest number here is 35. And then 37 occurs 2 times. 35, 37, 37. And then 40 occurs twice. 1, 2. And then we have 43. And then 44. And then 47. And then 49. So from smallest to biggest in ascending order, we have 35, 37, 37, 40, 40, 43, 44, 47, 49. To calculate the range, let's write that formula down. So we have range is equal to your maximum value, subtract the minimum value. Super easy to calculate once you put the list into ascending order. So your maximum value is 49. The minimum value is 35, which would give me a range. 49 minus 35 is 14. Outliers. Okay, so at the start of the list, we have 35. Is 35 substantially smaller than 37? No, it's only off by 2. So I would not classify that as being an outlier. How about at the other end of the list? Is 49 substantially larger than the other numbers in the list? No, once again, it's off by 2. So in this case, how many outliers do you have? None. Because they are not substantially larger or smaller than any of the values in the list. That's what we want when we collect data in science. We want our results to be consistent. We don't have data points that are drastically off in comparison to the other ones. Okay, and then the final one. This one's a bit trickier because now we have some negative numbers. Okay, so the minimum value in terms of number, you can visualize this on a number line in terms of identifying what's smallest. So if my negative numbers, I have -8, I have -1, and I have -5. Which of those would be the smallest number on a number line? It'd be -8. On a number line, -8 would be the furthest over to the left. So we'd have -8, -5, -1, and then 8, 12, 13, and 26. So from smallest to biggest, -8, -5, -1, 8, 12, 13, 26. Let's calculate the range first. So my range would be equal to max minus min, which would be equal to 26 subtract. Now, I'm going to write down -8 in brackets so it doesn't look weird. So I'll treat it like the notation we use for integers. We have 26 subtract -8. To do this calculation, we need to apply one of our subtraction rules for integers. So what we have here is we are subtracting a negative number. When you subtract a negative number, when you remove some negativity, that is the same thing as adding a positive number. Removing negativity means you get more positive. Therefore, your range, 26 plus 8, would just be equal to 34. And then the outliers. Okay, let's start at the left-hand side of the list. -8. Is -8 substantially smaller than the next number in the set? Not really. It's off by 3 in comparison to -5. So I'm not going to classify that as an outlier. How about 26? Is 26 quite a bit off compared to the other numbers in the set? I'd say so. It's off by 13. So I would say your outlier here, you're just going to have 1, would be equal to 26. And that's it. We can practice determining range and outliers by doing page 437, numbers 3 through 8 in our Math Links textbook. And next time we'll look at what effect outliers have on determining the mean, median, and mode in a data set. And I will talk to you then.